Thank you for joining this session on accelerating modernizations and bolstering security with Zero Trust. My name is Agus, and I will walk you through drivers for Zero Trust adoption and how it relates to modernization. I will be joined by my colleague Jessica, who will describe the architectural pattern of Zero Trust to help you translate Zero Trust principles into practices. This is our agenda. First, we look at what's driving the need for new security model, specifically in the context of public sector. Next, we are going to cover the benefits and guiding principles to help you build the case for Zero Trust in your organizations. We then deep dive to how Zero Trust applies within AWS and how to build Zero Trust workload on AWS. Closing these sessions are key takeaways to accelerate your Zero Trust journey. What's driving the need for a new security model? Public sector need to strengthen cybersecurity posture to tackle sophisticated cyber threat. But how to improve cybersecurity posture further? Well, first to understand the shortcoming. Learning from past incidents, we have seen how an attacker managed to breach the perimeter of the network, gain access to the system, and make lateral movement from system to system within the perimeter. A perimeter-based defense approach is no longer sufficient. The new security model should make this lateral movement harder. Many governments adopt cloud-first strategy. The approach taken to secure the workload in the cloud, however, has largely been adopted from the same approach taken to secure on-premise workload. Many of the constraints in on-premise do not exist in the cloud. If you forklift the same approach towards security on-premise into the cloud, you end up with a bolted-on approach that is complex and inflexible. The shift to hybrid workforce continues to be the norm. And despite increasing deployment of internal government workload to the cloud, these workloads continue to strictly be accessible from internal corporate network. Public sector officer is required to establish VPN connection to on-prem network for accessing this workload. And this results in a strained IT infrastructure supporting the remote access. Along the same line, we see increasing trend to support a work-life balance. Workforce can't be in front of the corporate device all the time, but when they need to get the job done, they want to be able to do it from any devices as well. Digital transformation projects undertaken in public sectors are smart city, often involve edge computing, IoT devices, and sensors that are operating entirely outside of the traditional enterprise network. A new model to security is therefore needed, as traditional approach to network perimeter will not be able to secure such workload where they reside outside of the perimeter. To summarize, public sector needs a new security model to tackle the challenge of strengthening cybersecurity posture further, and at the same time allow public sector to continuously innovate to provide better public services to citizens. To address this, a forward-looking approach is needed towards security. You may have heard several governments leading the path with clear mandate to adopt Zero Trust. So let's take a closer look at what is Zero Trust. From the definition standpoint, Zero Trust is a set of mechanisms that focus on providing security control around digital assets that not solely depending on network controls or network perimeter. The key points from this definition are Zero Trust is a model. It's not a specific architecture, a specific service, or a specific technology. Zero Trust is a move to broaden the focus of security beyond network firewalls and network controls in general. But Zero Trust doesn't remove this network control. Instead, it augments it with the identity control to address the shortfalls in network controls. Undertaking change needs to bring benefit. A clear alignment on benefit not only accelerates the adoption, but also maximizes results from the change. Let's relate back to the challenge presented earlier. First, use Zero Trust to raise the bar on cybersecurity. Take full advantage of identity-centric and network-centric controls to further improve your cybersecurity posture. Second, encourage your engineering team to build a modern workload, utilizing native cloud capabilities that make it easier to secure. Allow security to be built into the workload rather than layered into. Third, use Zero Trust to provide better user experience on access to resources, whether it's external facing or internal resources, by your staff or contractor, from corporate or personal devices. Fourth, as more and more IT workloads move closer to the edge to minimize latency and improve user experience, use Zero Trust as an enabler to secure this innovation. In the journey to adopt Zero Trust to achieve those outcomes, you will encounter different views of how Zero Trust should be implemented. A guiding principles will help you deal with this conflict. So let's discuss 3 guiding principles that you can reference for your organizations. On the implementation of Zero Trust, focus on the specific problems that you are trying to solve and avoid getting mired in low-value discussion. Zero Trust can mean different things in different contexts, whether you're adopting Zero Trust to secure your internal machine-to-machine communication, to secure human to access to your application, or to secure your digital transformation initiative. The same technical principles applied towards different objectives and use cases could result in different approach and solution toward implementing Zero Trust to achieve the objective. Therefore, it is important to always work backwards from the use cases and objective. While the conceptual model of Zero Trust decreases reliance on network locations, the role of network control and perimeter remains important to the overall security architecture. In other words, the best security doesn't come from making a binary choice between identity and network controls. It comes from using both effectively in combination with each other whenever possible. And optimally, you would like to make both of these controls aware of each other. You could build data perimeter in the cloud using both identity-centric and network-centric controls to ensure access to the right resources with the right identities from the right network. Consider not just the security of the system, but also usability and flexibility of the systems. When security trumps everything, you end up with a system that cannot meet business needs, or one that no one uses. So don't issue inflexible mandates on Zero Trust. And also don't aim to find the one-size-fits-all Zero Trust solutions. Apply Zero Trust in accordance to the value of the system and data being protected, so the benefit will commensurate with the effort. Successful implementation of Zero Trust requires flexibility to deal with the limitation in your workload and the creativity in how to work around those limitations. So let's move a step closer to implementation. After working backwards from specific use cases, when you are building Zero Trust workload, instead of figuring out whether a particular product or services are Zero Trust, the architecture of the workload must be evaluated as a whole on a set of attributes that exhibit Zero Trust. Therefore, it is important to expand the Zero Trust definition into a set of Zero Trust attributes. So these are the 4 attributes that you can reference as a start. The first attribute focuses on ensuring that resources and data are accessed securely, regardless whether the requester is human or machine, or the requester network or physical location. A strong authentication should be enforced. A strong authentication for human requires at least multiple authentication factors. A strong authentication for machine requires a cryptographic-based authentication mechanism. Authorization should be granted with least privilege. Achieving least privilege, however, could be a journey. So ensure that you build the mechanism to continuously perform permission right sizing. It's important as well to ensure that these strict access controls applied consistently not only on human to application, but also machine to machine. The second attribute is microsegmentation. Microsegmentation plays an important role on reducing blast radius of an attack, making lateral movement harder. To achieve microsegmentation, apply it at various levels. First, separate workloads into multiple accounts, using accounts to provide the boundaries and controls for communication between workloads. Within each of these accounts, break the system down further into a smaller logical components. Build a micro perimeter around these components with a combination of identity and network controls. The third attribute seeks to prevent exfiltration by continuously monitor the behavior of user and network traffic even after access has been authorized. To achieve this, advance the granularity of access by authenticating and authorizing each request. Use a short-lived ephemeral credential as opposed to long-term credentials to mitigate impact from a stolen credentials. Perform continuous security monitoring to detect abnormal behavior in user access and network traffic. And if abnormal behavior is detected, orchestrate the response in automated manner. The fourth attribute focuses on how to eliminate emotion of trust from digital system. The zero and zero trust fundamentally refer to diminishing trust. We should seek to use mechanisms not only to verify trust, but also to reduce the potential abuse of trust, not only by system, but also on human, especially privileged access. So all network traffic must be inspected and logged. Use encryption to further protect your data in transit and at rest. Use automation as the primary mechanism for operation via two ways. First, adopt an immutable infrastructure to reduce human access. Second, convert your operational procedure and tasks into code and automate the execution by triggering them in response to events. So let's look at how we could build workloads that put these attributes into practices. Jessica, could you walk through us on how to build zero trust workload in AWS?
Thank you, Agus. Hi, I'm Jessica. Before we go into building Zero Trust on AWS, let's look at how Zero Trust is used within AWS. The most prominent example of how Zero Trust within AWS is how millions of customers interact with AWS every day, using services such as AWS Management Console and AWS API. These are reachable from the internet. How does AWS ensure the security of this interaction? There is nothing about the security of the AWS API infrastructure that depends on network reachability. Each of these requests are authenticated and authorized every single time at rates of millions of requests per second. Our customers do so confidently, knowing the cryptographic strength of the underlying transport layer security, augmented by the AWS Signature v4 signing process. What AWS Signature v4 do is to add authentication information to the AWS API request sent by the HTTP, so we know who made a particular interaction with AWS and whether they are authorized to make that call. You can see how AWS Signature v4 signing process properly secured this request without any regards to the trustworthiness of the underlying network. Interestingly, the use of cloud-based API is rarely, if ever, mentioned in Zero Trust discussion. Perhaps this is because AWS led the way with this approach to securing APIs from the start, such that it is now assumed to be a basic part of every cloud security story. Our next example is how Zero Trust is used within AWS, is when two AWS services need to interact with each other on your behalf. We use the same mechanism that you use as our customers to interact with our services. In this example, let us take a look at application deployed on top of EC2, requiring access to data stored in DynamoDB. Here, IAM role is assumed by the EC2 to interact with Amazon DynamoDB. IAM policy grant the privilege required to authorize action on DynamoDB, such as get item or query. The act of assume role results in short-term temporary credential used by EC2 used in Signature v4 signing process. When DynamoDB service receive the request, it validates the signature for authentication and then authorize the request based on the policy attached to the role. You can see how even though both are AWS services, they have no inherent trust and uses strong identity control as the basis of security model as they operate on your behalf. Another great example of Zero Trust capabilities can be found in AWS IoT service. When we launch AWS IoT service, we mandate TLS encryption and modern client authentication in the form of mutual TLS certificates when connecting IoT devices to our service endpoint. When you want to connect broader AWS services outside of the IoT family, we include a mechanism to do trusted credential exchange so that you can exchange certificates for AWS short-term credentials that are necessary to do Signature v4 process. And every time you connect to one of these endpoints, you are using encryption and you are using modern authentication mechanism. We subsequently added TLS support to free RTOS, enabling modern, secure communication to an entire class of small CPU and small memory devices that were previously assumed not capable of it. In summary, the adherence of these AWS security standards brought Zero Trust Foundation to a domain where vast amount of unauthenticated, unencrypted messaging was previously the norm. Let's now turn our focus on how to build your workload exhibiting Zero Trust attribute on AWS. Example workload that I will run through is a mobile application backend using microservices. Use of mobile application is prevalent in the delivery of public services to citizens. In this workload, the mobile backend is deployed on serverless compute service, AWS Lambda. The front-end mobile application interfaces with the backend by API using Amazon API Gateway. The workload also uses other AWS services such as Amazon Aurora for data store, Amazon DynamoDB for session store, and Amazon SQS for queue service. First of all, how do we validate that access request to the backend is performed by authorized user? You can secure human-to-application interaction in this workload by integrating Amazon Connector with Amazon API Gateway. Amazon Connector enforces strong authentication via multi-factor authentication. You can also enable adaptive authentication in Connector that take into consideration location and devices to detect and block unusual sign-in requests. Successfully authenticated user will be given a token, granting ephemeral access to Amazon API Gateway. API Gateway protects the backend services by validating the token and performing authorization check on incoming requests before allowing or denying the request to Lambda. We have secure human-to-application. Now, let us look at securing machine-to-machine interaction. Each Lambda function configured with unique execution rule run with least privilege permission. When Lambda assumes the execution rule configured, it receives AWS short-term credential and uses this credential to sign requests using the signature before process to the appropriate AWS API. The ephemeral nature of the token issued limits the exposure even if it is compromised. To secure access to data store from your application, you can use AWS Secret Manager. In this workload, Amazon RDS proxy is used as a proxy to manage connection pooling to the database. Secret Manager eliminates the need to embed credentials in application code. Hence, even the developer will not have access to the database password, therefore keeping the password safe. We have added strong authentication and authorization consistently on human-to-application and machine-to-machine within this workload. Next, let's apply microsegmentation to reduce the blast radius of a successful attack. You can apply microsegmentation via security groups. A security group acts as a virtual firewall, controlling the traffic that is allowed to reach and leave the resources that is associated with. Security group of each of these Lambda functions is configured to only allow access to required target security group, such as Amazon Aurora Security Group or Interface VPC Endpoint Security Group. The target security group are also configured to only allow access from the specific source Lambda security group. For example, the first Lambda that needs to interact with Aurora via RDS proxy will not be able to interact with other resources, as security group restrict the allowed traffic only with the RDS proxy. On AWS, you can use a combination of identity-based policies, resource-based policy, and endpoint policies to establish data parameter. These policies, used together, create a preventive guardrail as access to trusted resource is restricted to trust identity from only the expected network location. For example, you can increase access granularity by configuring resource-based policy on SQS to restrict access to your SQS queue from only your VPC. This prevents your SQS queue from being accessed from other internet or another network. You have seen how identity and network capabilities work together to reduce the attack surface and limit the blast radius from a security breach. Now, let us move on to how you can seek to prevent exfiltration through continuous access evaluation. You want to assign unique roles with corresponding permission. But managing a large number of roles and validating the least privilege required for each role could be challenging. You can use AWS config to perform continuous evaluation of roles, to identify unused roles and excessive permission via last information in IAM Access Advisor. Automation can also be configured to remove excessive privileges. For continuous security monitoring, Amazon Guard Duty provides threat detection services. By monitoring CloudTrail, VPC flow log, and DNS log, Guard Duty identify malicious activity and anomalous behavior in your AWS account and workload with a combination of threat intelligence and machine learning. Guard Duty send findings to AWS Security Hub, which could be used to trigger custom action or remediation or orchestration. Let's now move to how you could reduce potential abuse of trust on this workload. By inspecting all incoming traffic, AWS Shield Advanced and AWS WAF provide protection against distributed denial of service attack and common web exploit. To further protect data from unauthorized access, data must be encrypted at traffic and at rest. Effectiveness of encryption relies upon cryptographic key and certificates. Hence, it is important to adequately manage cryptographic key and certificate lifecycle. You can do so with AWS Management Service and AWS Certificate Manager. Overall, this architecture makes use of managed services and serverless compute services, eliminating the need to manage the operating system image and operational overhead associated with server management. It also encourages the team to use automation and infrastructure as a code for deployment and operation of the workload, keeping people away from data. You have seen how Zero Trust could be built into the workload with strong authentication and authorization, enforcing strict access control on both human to application, machine to machine. Next, apply microsegmentation with both identity and network capabilities to reduce attack surface and limit the blast radius. Seek to prevent exfiltration with regular access evaluation through the use of ephemeral credentials, continuous security monitoring, and response orchestrations. Finally, reduce potential abuse of trust through traffic inspection, data encryption, and immutable infrastructure. And most important, how Zero Trust not only enable, but also encourage adoption of modern architecture to your workload. We hope the architecture pattern presented inspire you to apply Zero Trust to your workload. To wrap up, let me summarize key areas you would like to cover as your next step in this journey. Understanding Zero Trust starts with learning more about AWS networking services and AWS identity services, so you could evaluate the appropriate combination of network controls and identity controls for your workload. A strong network setup is the foundation of any AWS environment. Use the networking services on AWS to reduce your network complexity, improve security posture, and upgrade your ability to monitor and manage your network. Start with Amazon Virtual Private Cloud to easily launch your AWS resource in a logically isolated virtual network. As you apply microsegmentation at the account level, breaking down your workload to multiple accounts and multiple VPC, make use of AWS Transit Gateway and AWS Private Link to simplify your network communication across network. Zero Trust security model requires users and systems to strongly prove their identities and trustworthiness, and enforce fine-grained authorization rule before allowing access. Use the identity services on AWS to manage identities, resources, and permissions securely and at scale. With AWS Identity Services, you can centrally govern and manage AWS account within your organization. As demonstrated earlier, make use of AWS Identity Services to leverage short-term credentials for your user authentication and service authentication. Use a combination of identity-based policies, resource-based policy, and endpoint policies to establish data parameter, ensuring access to right resources with the right identities from the right network. Last, continuously monitor permission and usage to apply the principle of least privilege. You can learn more about Zero Trust on our website. Our Zero Trust landing page provides resources, including how to implement Zero Trust in IoT solution with AWS IoT services. You can get hands-on through workshops on implementing Zero Trust workload on AWS. Similar to early cloud adoption by public sector, adoption of Zero Trust will encounter resistance. The immediate challenge would be change to workload and conflict the existing security policies that are not aligned to Zero Trust. Taking lesson from cloud adoption, alignment of critical public sector leaders and their sponsorship is critical in accelerating Zero Trust implementation. Public sector should not aim for one-size-fits-all approach towards Zero Trust. Implementation should allow flexibility, recognizing the uniqueness of challenges and use cases. This can be achieved through establishment of guiding principles and attributes. Next, provide architectural pattern that could be referenced into various types of application workload, like what you see earlier. Cloud provides you with distinct security capabilities that can't be achieved on premises. Make the most of native cloud capabilities to raise the bar on security. We encourage our public sector customers to think about how your existing workload can be modernized with Zero Trust, and to use Zero Trust to enable innovation in public services. Thank you for attending this session and hopes you enjoy the remaining tracks. We encourage you to explore our training and certification content. AWS Skill Builder is our online learning center that make it easier for anyone to build AWS cloud skill. We offer more than 500 free digital courses in up to 16 languages. As you build your skill, considering preparing for AWS certifications, our industry-recognized certifications span foundational, professional, and specialty level to validate AWS knowledge and skills, building your credibility and confidence. Scan the QR code on the screen to get started with your cloud skill training and certifications. Before we let you go, we really appreciate your feedback. We appreciate if you could take time to fill out our survey and let us know what you think. Thank you again for attending this session, and I'm looking forward to connect with you. To use security as enabler for your innovation in public services.